Hi, we now look at examples where we differentiate by combining the chain rule with other rules of differentiation. In our first example, we want to differentiate x squared times e to the 5x. In order to know which rule to apply first, we need to ask ourselves what is the basic structure of this function. This function is written as x squared times e to the 5x. Is this a product, a quotient, or a composition of two functions? Pause the video and try to figure this out by yourself. Since we are multiplying two functions, x squared and e to the 5x, this is a product. So we use the product rule first. Our derivative is equal to the derivative of x squared times e to the 5x plus x squared times the derivative of e to the 5x. The derivative of x squared is simply 2x, but the derivative of e to the 5x is not straightforward. In particular, it's not e to the 5x. We need to ask ourselves here to differentiate this expression what the basic structure of e to the 5x is. Is it a product, quotient, or a composition of two functions? Again, pause the video and try to figure it out. Here it's a composition, and e to the 5x is of the form e to the u, where u is the function of x, 5x. So we need to use a chain rule here. Since the derivative of e to the x with respect to x is e to the x, the chain rule version of this rule is obtained by replacing x by u and multiplying by du dx. So the derivative of e to the u with respect to x is e to the u times du dx. Replacing u by 5x, we get e to the 5x times the derivative of 5x with respect to x, and that gives us 5. So overall, we get a derivative for the initial product of 2x times e to the 5x plus x squared times e to the 5x times 5. So you'll recognize that e to the 5x times 5 is what we obtain by using the chain rule to differentiate e to the 5x. Factoring a common factor, we finally obtain x e to the 5x times 2x plus 5. In our last example, we have a quotient of two functions raised to the 6th power. This is a function of the form u to the 6, where u is the quotient in the brackets 2x plus 1 over x minus 1. So we use the chain rule version of the power rule first. We get 6u to the 5 times du dx. Replacing u by the quotient, we obtain the following expression. Since u is a quotient, the last derivative needs to be done using the quotient rule, and it becomes 2 times x minus 1 minus 2x plus 1 times 1 over x minus 1 squared. So you'll recognize the quotient rule here, which is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. Expanding the numerator gives the expression on the left-hand side, and simplifying gives minus 3 over x minus 1 squared. Finally, we can write our final answer in a nice way by first regrouping the constant factors 6 and minus 3 together to get minus 18, and second by writing 2x plus 1 over x minus 1 to the 5th power as the quotient 2x plus 1 to the power 5 over x minus 1 to the power 5. Since in the denominator there is x minus 1 to the power 5 times x minus 1 to the power 2, it becomes in our final answer x minus 1 to the power 7.